Okay, we want to go through a demonstration today in electrical wiring class for eye construction on Ohm's law. Ohm's law, on this lesson, we're showing the mathematical relationship between volts, amps, and ohms in an electrical circuit, how they're set up. And quite simply, voltage or volts is electrical pressure. This is what's kind of like pushing the electricity, the current, through the wire. It's kind of like pumping water through a pipe. So we're going to put that down as electrical pressure. Amperage is the actual flow. In this case, we're talking about the flow of electrons. Number of electrons flowing by a certain point. We'll put that down as flow of current of electrons at a given point. So you'll hear the term current. And then in every system there seems to be friction. And ohms are going to represent electrical friction. This is what causes electrical wires to heat up, electric motors and things like that to heat up. Ohms friction, sometimes a good thing for a hair dryer or toaster. It's a great thing. But when you're running electrical cords underneath the carpet and the carpet catches on fire, we overload a circuit, catches on fire, that's a bad thing. So we always have to fight, kind of like maintain the friction and keep it under control. So this will be electrical friction. So we have to balance out the three. So in any given circuit, we're looking at a mathematical relationship that first of all sets up volts will be represented by E. We'll put a big capital E here for electromotive force. Okay. Equals volts. I will represent amps, and people ask, why don't we use A? Well, we're talking about inductance or inducing current to flow. So when Ohms was putting together this setup, we used I to represent amperage. And then we use R to represent resistance. This will be ohms in the form of resistance. E, I, and R. So the basic equation that we look at is voltage equals amperage times resistance in a circuit. We would look at that, and so we can write that in we can use the symbols, and we can also put down volts for those who like to have it written out for an explanation. Volts equals amps times ohms. So example wise, we could say we've determined in a circuit with a meter, we've measured, hey, there's 20 amps and 12 ohms that we've measured for resistance with the meter, a volt, amp, ohm meter. We can switch whatever dial we want, digital or analog, and measure. And if we put those two multiplications together, that means that there's 240 volts at that time in the circuit. So 240 volts would come from 20 amps and 12 ohms. So usually mathematically you are given two of the three things here and find the third one, solve for the third one when trying to figure out what's happening in a circuit at a given point. And the reason why we need such a thing is your electrical wires, your devices are rated at certain power loads and amps. The wires are rated like this, so the electrician's got to make sure whatever's on the circuit, the wire has the capacity, or what we call ampacity, to carry the load and not overheat and not burn the house down. And your circuit breakers match what your wires can carry, because if your circuit breaker is too small, we're going to trip too soon. Or if the circuit breaker is too big for what's on the load the wires can hold, then the wires heat up and melt and the circuit breaker never trips off. So that's why this becomes crucial as far as trying to figure out. So mathematically, we set that up, E equals IR. So if we do a little algebra, we can flip this around, and we can say, okay, amperage, and yes, that's where algebra comes in. Algebra is everywhere. So we've got amperage equals voltage divided by resistance. We can show that one. So that's we can flip that around. So amps equals volts divided by ohms. And the other one, we can take that equation, we can flip around, we can solve for ohms if we know the other two. We can say, okay, ohms equals voltage divided by amperage or amps. We can run it that way, E over I. And once again, if we don't like symbols, we've got volts divided by amps. And you can put numbers in and plug those in for the formulas too. So we always find out what's happening at a given point in the circuit. And really, depending on how many devices are on, you're not going to draw all these amps at once. You have the capacity or ampacity to draw if everything's on at once, but the wires are rated to carry the load. And most of your United States households are going to be, it's going to be a 240 volt circuit, which can be 240, 230, or 220, depending on the voltage drop. And then what's being fed in, and then you have your circuits that are going to be either 110, 115, 120 volts. Most of your household circuits are that. And then some of your other circuits would be either the 220, 230, or 240, based on those circuits. So calculating on this, if we're solving for amperage, let's go back to our example here. If I'm solving for amps, we're going to put in our voltage, once again, was 240. But let's say this time we discovered we had 15 ohms on the circuit. So if we do our math, 240 divided by 15, we would be at 100, or 100, yeah, I don't want that much. We could have 16 amps flowing through the wire at that point. So you want to make sure you got a electrical wire that can handle 16 amps, and usually electricians will plan for something above that. Let's say 20 amps, because most of your circuit breakers you'll see 15 amps, 20 amps, and they'll go from 20 to 30 amps, and they'll make sure they have a little built-in cushion that the wire and the breaker can handle. And then if we're solving for resistance, the other one was, if we brought in, we're solving for ohms. And we happen to see, okay, I got 120 volts in the circuit. And we notice that we've got 15 amps at one time. We're measuring, everything's on, 120 volts, pushing 15 amps through there. How much electrical friction does it generate? Then we're going to show that mathematically as 120 divided by 15, which should be 8. So we have 8 ohms of resistance at that point. So what's supposed to happen with your overcurrent protection is if we have an excessive amount of resistance that causes the wires to overheat, or we're exceeding our ampacity, too much amps for the wire that's listed, then the breaker should trip off. The fuse blows or the circuit breaker trips, and we have to solve the problem before we reset it, because it'll trip again until we get the problem solved. So that's part of kind of like keeping the house from burning down based on an electrical problem. So that shows the mathematical relationship for Ohm's law. At this point, we're going to give you some practice problems and have you calculate some different voltage, amperage, and ohms resistance for different circuits.